Now, addition and multiplication have a very nice relationship. We defined multiplication in terms of addition. That's also true of multiplication and exponentiation, or exponents. We said, hey look, this exponent, it's repeated multiplication. Just like we said, hey look, this multiplication, it's a repeated exponent. So if I take that same situation that we had with addition and say instead do, oh, I don't know, we'll say 3 times 2 to the 5th, which according to what we know would be 6 to the 5th, which is 7,776. We could instead say maybe we can go ahead and slip this exponent inside the parentheses somehow, similar to like we did with the addition and the multiplication. And just like we did with that, we're going to go ahead and say, look, this is this guy 3 times 2 times 3 times 2 times 3 times 2. We're at 3, so this will make 4 and 5 multiplications of 3 times 2. And then, like I said, 5 multiplications. This is all multiplication. So we can go ahead and reorder it into 3 times 3, 2, that makes 3, 4, 5, and multiply that by 1, 2, 3, 4, 5 2's. Look, we've got 5 of these, and we've got 5 of these. So this becomes 3 to the 5th times 2 to the 5th, which, if you go ahead and you figure it out, is 243 times 32, which turns out to be 7,776. So, in general, we could go ahead and write, if I have x times y to the, we'll use a again, a power, that's equal to x to the a times y to the a. We take this exponent, and just like we did with the multiplication, doink, doink, we hit both the x and the y with that exponent. And again, the situations where you would use this are similar to the ones with distribution. You might have something like 4x cubed, and you can write that as 4 cubed times x cubed, or let's see here, 4 cubed should be 64, x cubed. Let's check this. 64, alright. 64x cubed. And again, we just took this and doink, doink, hit both these guys with the 3. That's a really nice, useful thing. And again, it's the distributive property. And it has 2 flavors. Flavor the first is between addition and multiplication, and flavor the second is between multiplication and exponents. Now, one of the interesting things that you're probably familiar with that can kind of get a little life breathed into it and kind of be a little bit of a interesting moment with distribution is fractions. So let's take some fractions here, and we'll take, say, 5 divided by 7, and I'm going to add it with 3 divided by 7. And what I'm looking at right here is that division by 7. Oops, I want to grab my blue. I like blue. I've got division by 7. And I can anti-distribute. That's one of the ways you can think about it. Or factor, anti-distribute, factor, same idea. Division by 7, or 1/7. And that's kind of an undoink, undoink. And then it's 5 times 1/7 plus 3 times 1/7. 1/7 times 8, or just 8/7. And this right here explains why we need a common denominator to add fractions. because if we don't have that common denominator, I can't write an expression like this. I can't pull a 9 out of here. Then what do I pull out of here? 20 and 9, they don't go together. So if I wanted to add these guys together, we have to get it in a common denominator so that it's expressible like this, and we can get around the order of operations. That's what adding fractions is about. It's about getting around the order of operations. We're doing this addition over here before we're doing the multiplication. Whoa. So how would we do this? I always just say, take the one denominator, multiply the other guy by it, so you get 99. Take this denominator, the 20, multiply this guy by it, so you get 80. And then our new denominator is whatever 9 times 20 is, so 180 over 180. And add these guys, so that'll be a 9, a 7, a 1 over 180. And if we have this form, again, we can write this as 1 divided by 180 times 80 plus 99. That's why when we're adding fractions, we just add numerator to numerator and leave the denominator alone. It's a distribution thing, and that's kind of cool. I know certainly when I was first learning this, it was like, no, you don't. Was the big explanation that I always got from my teacher. You don't. Well, think about if you had a pizza. I don't care about a pizza. I'm thinking about numbers here. Why can't I? Is there ever a circumstance where we do? When do you mess with the denominators? Well, you would mess with the denominators during multiplication, because again, this is just multiplication. So if I had some multiplication, then I would certainly, 4 times 3 is 12, 5 times 8 is 40, mess around then. But with addition, you don't. And again, this is all the same operation here. This is all multiplication. Okay, that was order. Thanks.